Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is vector addition and subtraction. Vector addition and subtraction are the important vector operations that we will frequently encounter in vectors. There are actually two methods for vector addition and subtraction. First one is graphical method and the second one is analytical method. We will particularly concentrate on the graphical method in today's videos. To add or subtract two vectors, we have to add or subtract the corresponding components. Let u be u1 and u2 and v be v1, v2. These are the two vectors. Then what would be the sum of u and v? So let me give you that. As I already told you, we will be adding the corresponding components for vector addition. So this is how we add the two vectors. Here I have taken two vectors u and v. So I'm just adding the corresponding one. Okay, now let us see the vector subtraction, the difference of u and v. Here is how we subtract the two vectors. We just subtract the two corresponding vectors. It is just like u plus negative v. Both are same, no? U minus v and u plus negative v. Okay. There is also one more name for subtraction and for addition. The sum of the two or more vectors is called the resultant. The resultant of two vectors can be found either by parallelogram method or triangle method. Also, the triangle method can be called as head to tail method. First, let us see parallelogram method. Now let me show you how to find the resultant using the parallelogram method. Draw the vectors so that their initial points coincide. It will just look like three vectors starting from the same point. Then draw lines to form a complete parallelogram. I have drawn the broken lines to complete the parallelogram shape. This diagonal from the initial point to the opposite vertex of the parallelogram is the resultant. For vector addition, place both u and v vector at the same initial point and then complete the parallelogram. The resultant vector is nothing but the diagonal of the parallelogram. So how would a vector subtraction be? Okay, same thing. U and v starts from the same initial point. Please note that v is starting in this direction. For vector subtraction, you have to complete the parallelogram. Draw the diagonals of the parallelogram from the initial point. Hope you are clear with this concept. Let me now explain you how to draw the vectors for triangle method. Please look at this figure. Draw the vectors one after the other, not from the same initial point like we did in the parallelogram method. For triangle method, we are just placing the initial point of each successive vector at the terminal point of the previous vector. Then we draw the resultant from the initial point of the first vector to the terminal point of the last vector. So this method is also called as head to tail method. Head to tail. Okay. I'll also show you the figure for the vector subtraction and then we can discuss about this method detailedly. So this is how the triangle will look like for vector subtraction after construction. There is a minus sign before v. The head to tail method is nothing but a graphical way to add the vectors. Let me explain you the steps for vector addition in head to tail method. Step 1. First, draw an arrow that represents the first vector. I'm going to draw 9 blocks to the east using a ruler and protractor. Step 2. Now draw an arrow that represents the second vector. I'm going to draw the second vector 5 blocks to the north. As I already told, this should be the starting point of the second vector. Place the tail of the second vector at the head of the first vector. Next step, if there are more than two vectors, continue this process for each of the vector to be added. This head should be the tail of the next vector and its head should be the tail of the next vector. So please note that in this example we have only two vectors. So we have finished placing the arrows tip to tail. Okay, now draw an arrow from the tail of the first vector to the head of the last vector. So this is going to be the resultant. The sum or addition of the two vectors. To get the magnitude of the resultant, measure its length with a ruler. So this is going to be, I get 10.3 units here and I'm using a protractor to calculate this angle. I'm getting 29.1 degrees. Please note that in most of the calculation we will be using the Pythagoras theorem to determine this length, because using of a ruler and protractor is not always helpful. That is one of the idea, but you can also use the Pythagorean theorem to determine this length. Okay, we saw how to find the magnitude of the resultant. So how will you find the direction of the resultant? To get the direction of the resultant, measure the angle it makes with the reference frame using a protractor. And here also, in the most of the calculation, we will be using trigonometric relationships to determine the angle. So you can use both the methods. So it is up to the question that you're getting. The graphical addition of vectors is limited in accuracy. Only the precision with the drawings can be made and precision of the measuring tools. It is valid for any number of vector. Vector subtraction is a straightforward extension of vector addition. To define subtraction, for example, we can say that we want to subtract b from a. Vector subtraction either can be written as a minus b, or you can write it as negative b. Okay, I'll explain how this is possible. We must first define what we mean by subtraction here. The negative of a vector b is defined to be negative b. That is, graphically, the negative of any vector has the same magnitude but the opposite direction, as shown in this figure. In other words, we can say that b has the same length as negative b, but they point in the opposite direction. Essentially, we just flip the vector so that they both point in the opposite direction. Vector subtraction is the extended form of vector addition. Yes, the subtraction of vector b from vector a is then simply defined to be the addition of negative b to a. Note that the vector subtraction is the addition of a negative vector. The order of subtraction does not affect the results. It will be the same. So this is analogous to the subtraction of scalars. That is quite different. Again, the resultant is independent of the order in which the subtraction is made. When the vectors are subtracted graphically, the techniques outlined that we outlined. Okay, let me give you one example. Here is the example. We are supposed to perform the vector operations that is given in the question. First one is subtraction, addition and subtraction. So in each case, we have to add or subtract the corresponding coordinates to find the result. And the only one helpful way to check your answer is to draw the vectors on a graph and showing the addition or subtraction and compare the results. The corresponding, for this one, the subtraction. So 3 minus 4 minus 1 and 2 minus 5 is minus 3. So minus 1 comma minus 3. You can compare your results with the graph. Okay, for the second one, we are supposed to perform vector addition here. So just add these two numbers and we'll get 9. And if you're adding this corresponding numbers, I'm getting negative 1. So 9 comma negative 1 for part B. And for part C, negative 1, negative 0, which is negative 1. And 0 minus 0 is obviously 0. So answer for part C is negative 1 comma 0. Because subtraction of a vector is same as the addition of vector with the opposite direction. The graphical method of subtracting vectors works the same as for the addition. Here is the next example. Here the coordinates are directly given. Okay, so you're going to substitute the given values u1 v1, u2 v2 into the definition of the vector addition. Vector addition definition is, now let's substitute the values. So 3 plus 5, 4 plus negative 1. So the resultant I'm getting here is 8 comma 3. Now rewrite the difference u minus v as the sum u plus negative v. Both are just same. Okay, we will need to determine the components of negative v. So please recall that negative v is a scalar multiple of negative 1 times v. From the definition of scalar multiplication, we have, so negative v is negative 1 times 5 and negative 1 times negative 1. So negative 1 comma 1. You can also refer a video on the scalar multiplication in case if you have any query. Okay, now add the components of u and v, negative v. So the resultant is negative 2 comma 5. So vector addition means adding the component of two vectors to form the component of a new vector. In graphical terms, this corresponds to the drawing the vectors as two arrows laid tip to tail and drawing the sum vector from the tail of the first vector to the tip of the second vector. And vector subtraction is same. It is performed by negating the vector that to be subtracted, and then we add, as we did in this example. We can also perform the same operations, addition and subtraction of vectors in analytical method. We can discuss that too in the following videos. In case if you have any query regarding this video, please let me know.